here we're going to put all of grasping rational functions, like all the parts together. The steps, if you need general steps to follow, first you're going to factor your numerator and your denominator. Then you're going to identify the parts, the points of discontinuity, which I'm shortening as POD, your wholes, your vertical asymptotes, and your horizontal asymptotes. Then you're going to draw any asymptotes that you found. So whatever you get for your VA and your HA, you're going to draw them on your graph as dashed lines. And then you're going to type the original problem, so what you started with here, in y equals in your calculator, making sure to put your whole numerator in parentheses and your whole denominator in parentheses. Okay, so starting with number 1, if you're trying to find the points of discontinuity, what you need to do first is factor everything. So this has a GCF of 2. Let's see, when you take that out, you're left with x squared plus 4x plus 3. And your denominator, just doing x box quickly in my head, let's see, that's x plus 3, x minus 1. And we do need to further factor that numerator. So that is 2 x plus 3, x plus 1 over x plus 3, x minus 1. Okay, now that we have that whole thing factored, we know we're looking for 2 points of discontinuity, and those are going to be the numbers in our denominator that would maybe, well, that if we had those values as x would make it equal 0. So right here, what plus 3 would give you 0? That's negative 3. And then what minus 1 would give you 0? Positive 1. Now that we know what those are, either they're wholes or vertical asymptotes. So with wholes, we're looking, was there anything that could have been reduced or simplified here that would cancel out? And since that x plus 3 could cancel with that x plus 3, that means we have a whole at x equals negative 3. And since that didn't cancel, that means we have a vertical asymptote at x equals 1. Horizontal asymptotes have nothing to do with this. We do all the factoring and stuff to fill this in. The horizontal asymptotes, we're looking at the relationship between the powers, the degree of our numerator and denominator. Since these are the same, since 2 is equal to 2, that means they're equal, and we're looking at the ratio of the numbers in front. So 2 divided by 1 is 2. So that means we have a horizontal asymptote at, here, let's get, so 2 over 2, and then 2 over 1 is where we get that y equals 2. Okay, now that we have all our parts, we identified everything, we want to draw any asymptotes. I really think of these asymptotes as fences for the function. So where x is 1, so I'm going to go over 1 to where x is 1, and I'm going to draw a dashed line. For my horizontal asymptote, I'm going to go where y is 2. So I'm going to go up 2 on the y-axis, and then I'm going to create a dashed line there. And now that I have those fences set up, I'm going to graph the original function in my calculator, putting this whole numerator in parentheses and this whole denominator in parentheses. And when I do that, I'm going to get something that looks kind of like, I'm going to have a curve in this window here with the fences, and I'm going to have a curve in this window here with the fences. And this is probably not perfect, but that's about as good as I want it from you. Now the only thing I've left out as far as the graph goes is that we had a whole at x equals negative 3. And some of you have probably noticed that your calculator hasn't drawn a hole for you yet. It's not going to. So what you have to do is go over to where x is negative 3, and on the curve you're going to put a little open circle to represent your hole. And that is the rough sketch of this function with all important parts considered. Okay, example 2. Step 1 is to factor numerator and denominator. And this one, our numerator needs nothing. In our denominator, we have a GCF of negative x. And then that x squared minus 9, the difference of squares, so that gets further factored into x plus 3, x minus 3. Okay, so our points of discontinuity are any values of x that would make our denominator equal 0. And we know we're looking for 3. So right there, for that x, we have a point of discontinuity at 0. For that, it would be negative 3. And for this one, positive 3. Now that we have those established, those 3 are either wholes or vertical asymptotes. Our wholes are anything that cancels. So since the x, I did the green. Alright, so since this x can cancel with that x there, that means we have a whole at x equals 0. And our vertical asymptotes are the ones that don't cancel. So that means we have a vertical asymptote at x equals 3. Well, negative 3 and 3. Our horizontal asymptote, we go back to the original function and we look and see. Okay, in this we look and see the relationship between the highest power in the numerator and the highest power in the denominator. Now that's an understood one. So 3 is bigger than 1. Since our denominator power is bigger, that means we're going to have a horizontal asymptote at y equals 0. Now that we have our framework set up of information, we need to draw our asymptotes over here. So where x is negative 3, 1, 2, 3, we're going to have a vertical asymptote, a vertical dashed line. Where x is 3, we're going to have the same thing. And then we're going to have a horizontal at y equals 0. And this is a little weird because that is your x-axis, so just make sure it's clear when you're drawing this that you have some kind of dashed line on that x-axis. Okay, almost done. Now that we have our asymptotes sketched, we can throw on the shape of the graph, the curve. So you're going to put the original function in your calculator, putting your whole numerator in parentheses and your whole denominator in parentheses. And don't forget the division bar. Some of you forget to do that after I say all the parentheses stuff. Okay, so put that in there, and when you do, you should get something where you have like a function trapped in this corner, and that it picks up here and makes this U shape here. And then in this thing here, it goes up and curves right. Okay, and it is really important that you understand those operate like fences. Like this black shouldn't cross that red. They get really, really close, but they're not going to cross it. And the one last thing I need to handle is the whole at x equals 0. So where x is equal to 0, I'm going to put a little open circle. And those are the basics.